Нурлан, я думаю, можно потихоньку начинать. Ребята пишут то, что чуть-чуть через несколько минут подключатся. Вот. И пока, я думаю, можно начинать.
Хорошо, спасибо. Меня слышно, да? Нормально слышно?
Да, слышно.
Ага. Хорошо, сейчас я шарю экран. Видно, да, мой экран? Алло, алло, меня слышно?
Да,
Да, я
видно.
вас не слышу. Все, спасибо. Значит, окей, давайте на английском, так как сказали, выступить попросили на английском, давайте на английском и выступим. Но если что, я говорю на русском, на казахском, можно. Думаю, в случае там, как если какие-то затруднения, можем немного переключаться. Okay, hi everyone. My name is Nurlan. I'm a software engineer. So today I'd like to talk about domain-driven development. Uh, First of all, thanks to Tericon Valley, which gave me an opportunity to speak about this topic. So today's agenda is like this. So first approximately 10 minutes, I will be speaking about theory of DDD, and then I will try to pay attention to practical example and spend some more time, about 40 minutes, and last 10 or 15 minutes, we can discuss these questions and answers session. So let's start. Before starting, let me introduce me about myself briefly. So I am a Java backend developer at DataArt. I have been working for DataArt for about 2 years, and my role is a Java backend developer. We are currently building a system on using this domain-driven development technology. So I joined this project in February this year. So it was an interesting topic for me, and today that's why I'd like to speak about DDD and discuss it with you, with Telecom Valley subscribers, listeners. And in the past, I have worked with as a full stack and tech lead, mainly in local companies. So my education, I got my master's degree from University of Melbourne, and then a bachelor from KBTU from Almaty. And I like go running, swimming, fishing, snowboarding. So if you have the same interests, you can follow me in Instagram and text me. I would be glad to meet, go somewhere, share interests, and etc. Moving on to the definition of domain-driven development. So this is a definition of DDD from Wikipedia. So domain-driven design is a measured software design approach focusing on modeling software to match a domain according to input from the domain's experts. DDD is against the idea of having a single unified model. Instead, it divides a large system into bounded contexts, each of which have their own model. To understand it, let's move to the next slide and have a look at this picture. So here you see such so-called hexagonal architecture. It has also another name like ports and adapters pattern. This architecture is closely related to DDD, even though they are different concepts. I would say this is one of the main implementation methods of domain-driven design. So if you see the picture, so you can see the application in the middle. It has a domain model. We can call it core module, and it consists on the domain models. And if you go beyond this core, you see many adapters and the external, let's say, external systems. By the way, hexagonal architecture, it doesn't mean, so we have how many edges here? 1, 2, 3, 6. It is not necessary to have exactly 6 edges. It might have any number of edges depending on the application. So just hexagonal is just a symbolic name for this architecture. And here by adapter it means external systems like database. It might be database or any other third-party systems like Kafka or any other clients or some REST APIs, and etc. So it might be anything which the application connects and grabs some data or changes some data. And this core module communicates with these adapters by so-called ports. Yeah, so it is not necessarily the physical port like hello, do you hear me? Okay, thanks. So sorry, I got the internet connection. So looks like now it's okay. So let me share the screen. Okay. So we were talking about this hexagonal architecture. I hope you heard the description of this. So let me repeat it again quickly. So the hexagonal architecture has core domain module and many adapters. Adapters are just external systems like database, Kafka, or any other RESTful applications or clients. So the core module communicates with them with this abstract thing called port. And another thing to describe is like so we have the application and we have so all the systems can be divided into two parts, like driver side and driven side, as you can see in the screen. So in the top left side you see test cases, human user, remote application, single page app, mobile app, message queue, and all of them are called driver side. So drivers or primary actors. So what is primary actor is the interaction is triggered by the actor. A driver is an actor that interacts with the application to achieve a goal. So any of these actors can do something to the application, like they can call the REST API or put message onto message queue and etc. So human user or any other remote application can interact. So and the driven side, so it's called driven actors or secondary actors. They provide functionality needed by the application for implementing the business logic. So they might be like database or any other remote application, SMTP server, so again, message queue, printer, and anything else that can. So the application just like connects these two sides in the middle. So what are the benefits of using DDD? So first of all, if we build software using domain-driven development, we get separation of concerns. That means so every domain. So we will be separating our project into many domains, so many modules, and each module will have their own functionality, and by doing that we will achieve kind of loosely coupling between different services and technologies, and maintainability that comes from the first benefit. So as the modules can be independent from each other, so we can maintain them differently. I mean, not depending on each other. So for example, one module can be replaced. If you replace database with something else, like some other storage, like S3 adapter, then you change only one module, and other modules will not be affected. And testability. Again, from this separation of concerns, we can test as a dependent, independent from each other. We can test them, test each module independently from each other. I think it will be more clear when we deep dive into some into our practical example. So let's move further. Yeah, so DDD comes with some costs. It's not free, of course. So when you build the system using DDD approach, you have to do some. It requires more resources, like mappings between core and adapters and communicating between them. So it might take some longer time to build the regular application, as you have to do some regular jobs. But once you build, you will get benefits. Of course, if you build your application using correct architecture. Otherwise, if you did something wrong, then it may lead to some problems in future. Then you need to refactor your code and etc. And one rule is the core module should not have any third-party dependencies. The main purpose of core module is just to build main functionality of your application. So let's deep dive into practical example. So I have so I have prepared simple Spring Boot web application with traditional like three-tier architecture. So in the session we will transform the application which uses hexagon architecture following domain-driven development. design. And afterwards, we will talk about today's session. You can ask questions and discuss. So here the links if you are interested in DDD. So this book is for beginners, and this one also can be useful if you want to move. I mean, you want to change your application to DDD, and this article is also you can try to read if you are interested. So let's change our screen to Pod. So this is a Spring Boot application built in Java. So if you are, just for case, if you are not familiar with Java, I think it is not a big problem. So the main idea will be the same for every language, for any language, and you don't have to understand everything. Just you can understand the main principles, and you can apply this technique for any language. So I don't know. Maybe some of you have some Java expertise, like with Spring Boot framework. If you don't have, again, don't worry. So this is just simple application, very simple application. As we have limited time, I prepared very simple application, and I will try to explain this hexagonal architecture by using this application. Note that the project I have worked on with by applying DDD principle is looks very similar to this. So by using this simple application, I hope I will be able to explain main principles. So what briefly discuss control. That means it has this is a web application. Yeah, I can just run it, and it has only one get method, orders, and this we have order repository. Yeah. This is an interface by using Spring Data. It connects to the database and retrieves these orders. So I use ORM here, Hibernate. So we have table in the database. Table name is order, schema DD the test. So I have prepared database preliminary. So this table has columns like ID, name, description, date, and our application just when we call the REST endpoint here for this hang. So let's wait. This method returns all the orders in the database. So for example, I have Postman here prepared, and I'm calling this orders method to get the orders. For some reason it's hanging, so I don't know. Let's what's hanging. Postman is hanging. Let's try to call it using browser. Just yeah, he is. So I call this using browser. So it returned me two orders, and that's it. So this control is responsible for orders, and we have DTO, data transfer object, and the entity, or the entity. This is our database table, and mapper is just for mapping. We don't return database, whole database, right? We just we may return only some parts of the table, but in our case, I return everything. As you see, this order DTO has the same fields as order entity, and so we are returning to the front all the fields by using this mapper, which maps. And the order repository is just a GPA repository, which responsible for connecting. So connecting to the database. So as you see, so this is that's it for this project. It has only one module. It's called server. So everything is in one module. Let's say that in one place. So it's kind of three-tier architecture. So we have database level, this order repository, and then yeah, we don't have business logic level here, because it's simple, and we have controller. So let me hide this. Yeah, sounds better. So let's try to transform this application into DDD pattern using hexagonal architecture. So as you have seen already, hexagonal architecture has core, like domain module. I will call it core module, and adapters. So let's create our core module. Create new module. Let's call it core, and it's in Java, Gradle, Java 21. For example. Okay, so now we have created, added our core module to our project, and that's what this test class. And let's change the package name to core to indicate that it's core module. So let's open my test core. So we don't need main method, but I will delete it later. And let's create core entity. What entity we have? As you remember, we have the project is about orders. So we have one entity, order. So I will create class order. I can add entity, or I mean also let's keep it simple. So just let's name it as order. So let's make it a record. Just to be short. Yeah, so this, by the way, I'm using Copilot, and it's suggesting me which fields it can have. So let's use this just to save time and energy, let's say. So it has UUID and we'll call that. So if we go to, where is our order entity? So we have ID name, description, date, and it has the same ID name, description, date. So in our example, the core module looks almost exactly the same. It has exactly the same parameters as the database, but it does not necessarily, because in practice, this database table may have some other fields like I don't know, modified date, some history change related parameters, I mean database columns, so which is not necessary in core module, but in our example, let's use that like this. So we have created order, entity, and what we need. So we will create another package. Let's call it repository. So we have, you remember, we have repository. So we can call it also port. So we are currently going to build port. So just to be simple, I mean, to keep everything simple, let's call it repository, and later we can rename it to ports if we have time. And I will create this order repository, and this will be in only interface. So as we are building core repository, so remember, we need to get all the orders. So it should have method like find all. Let's find all, and it should return all the orders. Yeah, so we have entity, we have repository. That should be all for the core module. So let's remove this main, create it automatically. Okay, so this is our build Gradle of core. This is our server, so we can reuse this Lombok plugin here. So copy and paste. Okay, that should be enough. So we have repository, and the next thing, we have only one external system in our application, right? Which is a database. In my case, it's a PostgreSQL database. So let's create a new module. And what kind of adapter it should be? Well, we can call it. So we have what database? So let's call it DB adapter module. So let's stop the application, by the way. And again, created this default main method. We don't need it now. And it created me this build Gradle. So if you open the DB adapter, so let's rename this to DB adapter. That's okay, I think. DB adapter. And yes, again, this adapter should have what in its DTO, data transfer objects, and one more package. We can call it. Let's call it again repository. So this DTO should be this one. So remember, in this order entity is located in server module. So I will just move, cut, and paste here. And one thing to say that it is not entity anymore. It is DTO because it's external module, external system database. So I rename this object DTO. And so this is not working at the moment because I only to add dependencies to the DDD adapter. So I will move this database related dependencies, all of them to our DB adapter module. So we have GPA, auto configuration, and the context SQL. Let's rebuild it. And now it should have this. I need to add here plugin. So I have some prepared things. So let's just, to save time, copy. This is some dependency management. This EDD, let's say adapter should be, and then dependency management. I have Postgres and then let's rebuild. Here we have working, and now it's not recognizing Lombok. So let's just copy the Lombok plugin. Okay, now it's working. So we have created this DTO, and in the repository class, I will create our repository implementation. So let's go with order repository input. And it implements our interface in core module on the repository. But anyway, this is suggesting something. Yeah, I can just yeah, it's let's move one by one just to make everything clear. So currently it's not, it can't see this repository because we haven't included core module into our DB adapter. So let's implement implementation project core. I have included our core module into our DB adapter module. Now it should, now it sees this. And this order repository has this only one method. So let's implement it. Order, and so let's implement. So to implement, we need this GPA class. So let's create another class, and then sorry, Java Persistence API. And basically, this is our this class. So this is interface, and should mark it repository just to make it flat access layer by using Spring Boot framework, and it automatically should connect to the database and grab the data. Yeah, I forgot to extend this GPA repository provided by this Spring framework. And remember, we have renamed our order entity to what? Order DTO, right? Because it has moved to adapter. So the adapter shouldn't have core entities. It shouldn't have entities. It should have only DTO, according to domain-driven development. So yeah, make it. Sorry, just yeah, and so repository. Yeah, that's it. Should be working now. So I have copied everything, and by default, this GPR repository provides find all method. So let's inject this repository into our main class, into implementation of our repository, and to use. So I will use constructor to inject this, and here I will call its find all method by default, and convert. So remember, this find all method returns order DTO, right? So our database table, but we need to convert it to our core module order. So I will need mapper here in our DDD adapter. So I will create a package mapper, and let's call it order entity mapper, or on the GPA DTO mapper. So it should be better name. And yeah, one thing when working with hexagonal architecture is you need to create mappers for each module. Whenever you create a new module like DB adapter or any other module, for example, if you work with Kafka, if you need to connect to Kafka or RabbitMQ or another message queue services, then you need to create new modules for each of them, and each module should have its own entities like order DTO, and you need to create mappers for each of them. That is some redundant job I mentioned before, because this remember when we are implementing this order repository from our core module, and it has only it has this core module, doesn't have access to our DB adapters, right? It doesn't know anything about database or Kafka, any other systems. It has only access to its own order core entities. In our case, it's order. So when we implement, we need to convert this our external DTO to our entities. So let's create the mapper. So we have to convert our order DTO to order. It should return order to order. Yes, so this copilot is suggesting me this method implementation. So let's just reuse it. Import this. It gave me a run name because it's just order DTO. from here, and it just converts our order PTO to our order. So let's use this mapper in our repository implementation. Let's import and to order PTO. Yeah, it's correctly suggested. So we have implemented our core order repository interface by using this GPA repository from Java and I mean Spring and this custom mapper. So let's close and we can remove it from here, from our server, old server module. And we also don't have here entity. We have only here what's controller, right? And let's open the controller. Yeah, it can't see now this order repository because I need to include these modules. For a server module of core, as this server module contains this main method, we have to implement all the modules here so that Spring scan these pins and initializes them. So we have core and DB adapter module. Let's rebuild. By the way, we have let's do some configuration into our DB adapter module. Let's create config class. It's called DB config, and this should just create beans. So let me just copy from my prepared things to save time. Briefly, so what it does is if you have worked with Spring Boot, then these are beans, and it should just initialize our. So when we call all the repository, it will return its this implementation and this mapper. So remember, we have created this and the mapper also on the GPA detail mapper. So GPA. Just new instance of the GPA detail mapper. And these things are related only to Spring configuration, not exactly to. So I will just copy and paste to save time. So we have keys, this DDD adapter. Yeah, it's correct. It's correct. And in our here we should also do entity scan. I mean not entity but component scan. So just again just Spring Boot configuration. So it just tells this Spring to scan this DB our adapter, DB adapter module, and initialize these beans. So when we call this method, yeah, now it's located in our core, so that's why it's. So this is our controller, and so this is our repository from the core, right? So when we run our application, it goes here to configuration, and it returns this implementation of this repository automatically. And what it. So let's go to say this our core. I mean, this mapper is located in our server module. It should map our order to order GTO. Order GTO is the object we are giving to the caller, to the front, for example, right? So we have renamed our order to order. So just make some refactoring here. So this order is a record at the moment, so that's why, because we access it directly, not so yet, but just so description, ID, yeah, name, description, and date. Okay, so now this we can delete this automatically created. So looks like we have transformed our project to hexagonal architecture. So we have created these new modules, core module, and DB adapter module. So note that let's recall this core module has order entity and the interface order repository, and we implement this interface in our database adapter here by using GPA. So this logic is implemented using abstraction, right? So we have implemented the interface. So for instance, if you in future, if you change your database, for example, in my case it's Postgres, you can change it to Oracle or even NoSQL or S3 backup or any other third-party storage. You have to change only this class, and whatever in controller or in our core module, it shouldn't be changed. It's persisted. You only change this implementation here. If it is GPA, if you can do GPA, then please use GPA, please. Or if you change your data storage, then you need to change here. But this contract remains the same. Okay. It's complaining to our old change. So let's try to build our project and see how it goes. And errors, maybe I forgot to implement or build successful. So let's run our project. So I have included these things. Oh, it says Tomcat started with on port 8080. That means application is running. So let's try to call our REST endpoint. Oh, cool, it works without any errors. So I got the same records from database, but this time application has been transformed to hexagonal architecture following the DD principles. So again, for example, this application is very simple. It has only one entity order, and but in real world application, you might have many entities and repositories, and its implementations, and many other adapters. Like we have only database adapter here, but in you may have like Kafka adapter, which listens from messages from Kafka broker and reads, consumes some messages. And again, so my main principle is the same for all of the adapters created, right? So these adapters should implement core module interfaces, like here, like this. And the contract should be declared in core module like this. And you again need to do some mappings, like transforming from database table object to core entity. For example, if you are using Kafka, then you consume Kafka message, and the message has its own format, right? And you need to convert this Kafka message to core entity, like similarly here. So let's imagine that this is order something like Kafka map, Kafka DTO mapper. So you will receive in the input order like Kafka message, something like that, and you have to implement its mappings to convert it to order from core entity, and implement its logic here. Here, our repository is like, remember this hexagonal architecture uses what? Ports. Its another name is ports and adapters pattern, right? Right. So we have here adapters, and these repositories actually they are our ports. So we can rename this repository to port, not order repository, but so let's go to definition. Order port, for instance, and yeah, you may want to also rename its method to something like something like port to find all orders, or something like that. So depending on your imagination. So actually, what I want to say is our repositories actually our ports. So yeah, one thing to remember is our core module. So if you go to our core module, it has Gradle file. So as you see, it doesn't have any third-party libraries here. This JUnit only for testing purposes, but currently we are not writing any tests, so it's created by default. And we can use this JUnit just to create tests, but no other third-party libraries. For example, if you go to the database adapter, then we have some other third-party dependencies here, like PostgreSQL library and this Spring frameworks configuration dependencies. And yeah, if you create Kafka adapter, you will use here dependencies for Kafka accordingly. But in our core module, we don't use any third-party libraries. That is one another like strict rule, which can be not so comfortable to work, because without third-party libraries, it may be difficult to do some things, depending on, this is our simple project, right? So if we make it more complex, so if we have only, I mean, some complex logic here, then, for example, you cannot use any third-party library. So you have only two options here, as I see it. First option is to implement manually everything, which can be tricky and not efficiently. So you can do some things manually if the logic is simple. But if you do some complex things like serialization and deserialization of objects to JSON and vice versa, so you have to create another adapter. Like, for example, I want to convert my object to JSON and get JSON string, and I'm not allowed to use any third-party libraries like Jackson object mapper. Then you have to probably create another adapter, another module, and call it like serialization adapter. So I will not create, just let's assume we have adapter created, and then in your core module, you will create another repository which has only one not only, but like this method. For example, let's assume we have created some repository, and the string to serialize to JSON, and some object, for example, order. And then you implement this repository. So it should, of course, it should be separate repository. I'm just explaining in a simple way. So you will need, in your adapter serialization adapter, you will need to implement this repository using some third-party library like Jackson object mapper. Okay. So that's what I wanted to explain. So I hope I was useful, and I was able to explain something, and probably you have some questions now. Probably let's discuss this. Any questions, suggestions? No questions. By the way, you hear me, right? You hear me very well. Okay, now I see this question in our chat. So let me read. Question from Dmitry. During the lecture, you said that Kafka can be used all together with TDD. How does processing domain events through Kafka affect the modeling of business logic in TDD? What changes might be needed in the event models or aggregators? Okay. So if I get your question clearly, so in our core model, we have what core repository, right? Repository. Okay, Bogdan is asking. Let's try to answer to a question of Dmitry from Dmitry. So this is not changed. So let's say we have Kafka adapter created here, and if this adapter has a listener inside Kafka consumer, I mean, and it consumes some message from Kafka, and we do similar logic. Like here, we first do mapping. So we have where is our mapper? So assume this one is not this one, but this one. So this is message from Kafka, and we convert it to our core module entity and do some logic processing. Basically, you can create some things like event pass, for example, and yeah, so event pass is like abstract thing, and this event pass is responsible for handling. So we will have abstract event pass and abstract event handlers. So, and then we will implement this event handler for each message. And this event pass, each time when message comes from Kafka, you go through, iterate through event handlers, through all of the event handlers. And then each event handler will process its own message. So if it is registered, so each event handler, let's say, is responsible for doing some logic. Like we have event handler for processing orders, and we might have another event handler for processing, I don't know, client requests or client feedback, something, let's say client request. And each event handler will process its own logic. So these handlers, all of these handlers registered in event bus. Okay, so well, I think if we start implementing this, probably we will sit one and a half, another 1.5 hour time. But the main idea is like this. So this is one option to implement to implement business logic from Kafka consumer. So each handler may be responsible for handling each type of message, for example, coming from Kafka. Okay. Did I answer your question? Okay, let's then move to the next one. How do you collaborate with domain experts during the development process in DDD? Do you collaborate with domain experts during DDD? Okay, so if you mean in my project where I have worked with DDD, then collaboration is in our team is quite simple. We have developers, we have team leads. So in general, in our let's say subdivision, we have about 4 or 5 teams, and each team has several developers, and each team is working on several microservices. So each microservice is responsible for responsible for its own domain, and the collaboration is simple. So our tech lead, who has been working for a long time, knows this business logic, understands business logic better, and just they just propose us some architecture, and if we agree, so yeah, if we don't have any other options, any other questions, so we just accept and implement those services. Otherwise, we can always discuss. So this collaboration is just directly. So we have tech leads and developers. So tech leads just they know the business logic better. So they just explain us how this service should work and how the core entities and the logic should be implemented, and the developers implement if everyone is agreeing, no any other options. Just usual collaboration.
Кажется, больше вопросов не видно. Думаю, тогда на этом можно заканчивать нашу лекцию. Спасибо большое за выступление.
Вам тоже спасибо большое за то, что присутствовали, и надеюсь, я был чем-то полезен.
Да, думаю, что были полезны. Мы соберем обратную связь от ребят, которые были на онлайн-воркшопе, вам передадим, и также смогу скинуть вам ссылку на запись.
Хорошо.
Все, спасибо большое вам за выступление. Хорошего вечера.
Спасибо, всем хорошего вечера. Пока всем.